Hello. Yeah. Hi everyone. Good evening. So, yeah, the topic today we are planning to discuss edge computing. Probably you guys right now already like many years we are working with cloud computing, but recently the technology is coined like kind of what's that like edge computing, and even we have one more fog computing as well as in the market. Because all these things actually to make our job easier, because the customer they need the data and it should analysis of the data for insight very fast, very quick, immediately. So that's we discuss about now, and let's move on. Is it working? All right.
It's a clip ready.
All right. Okay. So first of all, I must thanks to thanks to our team, data engineering letter, because I used to be part of this team actually, and used to go to a lot of meets up as well. So it's a great opportunity. I must say thanks to the team and Jamie and Harry as well. Thank you. Thanks a lot. Right. So this specific thing actually have a good enough number of slides, but I don't know, like we have a given time just 30 minutes, so I'll try to wrap it up as soon as possible. If you have any questions, any discussions, probably we can have it after the discussion, so that the next speaker is also ready, so it will be easy to carry forward, and as well as we can manage time, right? Okay. So the streaming, probably like everybody knows, like I think people are around from here, from cloud computing or data analytics, all the experienced guys would be there, right? So anybody new to this world, data streaming, data analytics over here? Good? Okay, you guys are new to this, yeah. So probably, so this is a new, just one, two people, 2 years, two. Anybody? You? No, not you, just you guys.
Oh, me? Yeah.
Okay, good. You also write, so my friend has been is there. Okay, fine. So this specific thing, the stream processing, basically when we are starting with our data analytics point of view, we have two type of process, a batching process as well as streaming process. What's the batching process? Just like the highlights. So the data will be stored on frequent basis, and then like we used to schedule some job, pick up the data, and we use for it is for analysis. That is the natural we used to do, and we build the reports, and whenever like that. It could be an on-demand report or like a head-up report we used to create it like when 20 years back when we were working with crystal reports and data report when we are playing on that. After that it's become SSRS, SSIS, all the stuff we play around now. Stream analytics. What is the stream analytics like? Immediately. Because the data has been generated by human being, it could be like man-generated data or else machine-generated. So man-generated data nowadays actually is going very fast because we are in the world of what, Facebook, Twitter, and all other the social medias are there for that. They're giving a review, all the stuff like very fast is moving on. So the data streaming is become a high demand rather than the batch process. That is the main actually. Most of the data engineering aspects, the push is to be. Do you have experience with the data streaming? Are you working with all those things? So most of the people they get the chances to that, but it's not a rocket science, it's a simple thing, but only if you're using appropriate tools and technology, then you can achieve this one. Okay, so I'm not going to read out all the things because this is for placeholder for me. So, right. So the definition of the significance of data streaming, as I said, the immediate data processing. I need to, then and then, I don't want any waiting time. And even we have waiting is very minimal. But edge computing even is reducing the time more than the actual streaming what now we are working. The cloud computing, for example, if I'm driving a car, the pressure, the tire pressure is a little bit low. What will happen? That will be captured and it will like transmitted to the through IoT, and it will transmit to the data analytics, and then it's sent back to your system saying that air pressure is low, and it say like the nearby what is that, like a gas station is there, you can go and fill all this information will be displayed for your easy to move on. How the data is transferred, because the data transfer from your IoT. So as I said, the two things, one is a man-made data and machine-made data. So obviously you know, right, so machine generating the data very faster than human being. So that is a thing actually we call it as IoT, Internet of Things. Probably you might know that. So actually when we were implementation is like during 2010 by the time, so we used like integrating from the plant level into the SAP level integration for order management perspective. So we used what? Exactly PLC level programming. So the PLC level programming will take the data and then we cascade it to the next level, then SAP level. So that we need to complete all the integration. So from order receiving and order processing, and then we used to create a lot of reports, all of the stuff. But IoT is once came in the picture, the entire things will get changed. Everybody there they are moving into IoT. Why means, so data will be transmitted then and there. But human is not always satisfied. They need more. They need more faster. So the simplest example I can say, so what is exactly the edge computing in simple understanding way. For example, if I want to carry this bottle, I'm going to take this one and put it down here. And then, but it should be very faster. Or it should be do something else. What I can do, instead of what I can pause with these guys. So I can ask this guy to, hey, can you please pause it? Quickly pause it. Then the time will be reduced. Isn't it? So this is a classical example with respect to the edge computing. Nothing is there, but here just the data transferring. But if I asking him to like, can you please assess the water is there or is there any other understanding with that, the water pet bottle, then probably he can give me the answer. Otherwise, I can ask, she's my wife as well. So I can say like, what is actually the analysis of the report? Instead of asking the endpoint, I can ask my Mr. Name sir? Satya. So I can ask Satya, can you please do it for me immediately? So he can access the data, he can bring me back. That is edge computing. Not a big deal. Okay? Right. That's all. Timely you can make a decision. Instead of asking like to fill the water, going and see, you can say that, yes, we need to take a decision properly. The pet bottle having nothing water, we need to refill that. So what are the insights you can understand, you can communicate to me saying that, Shanta, like we can refill the water. Otherwise, I have to go and stand there with the data, then where I have to analyze and get the result back to me. Instead of that, I can have an immediate store. This is another example, classical example I can say. So there might be some, M&S, the big store. Let's say it has like in very long back, like in London, we have one store, for example. In outer London, or else like the place where I'm living, we don't have a M&S. What we supposed to do? We have to come down, we have to come and pick up, like we have to buy the item from shop which is in London. If I have the M&S nearby, directly I can go there, I can get the things from there itself. So my time saved, right? So this is a simple classical example. It's not directly connected, but it's relatively connected. Think about that. Absolutely, the business competitivity is very improved because they can reach the people very quickly. That's one of the major things. So this is what I already mentioned, that batch processing limitations and all. I don't want to go through that. And right. The challenges with the real-time data processing. So real-time processing means, like for example, if you are like in school days or college when you're doing uni, what are you supposed to do? Like during the exams only, I used to do that. Because like during the exam time only, like you go and read all the books, go to the library, or else like go and find the French student, ask the notes and all, and go and read everything, right? Then by the time the volume of the, what's that? The information I to digest is very huge. The volume of the data will be very, very huge, right? And now we have the big data concept. The big data is nothing but what you know, probably 3 V's or 6 V's industries used to say. That is volume, variety, velocity, and all of the V's are there. isn't it? So all the data is like started after the internet was enabled. So the people started throwing the data on the internet so that the volume of the data has become huge and huge day by day. Even actually people are like scratching the mobile, you are giving it cheers, or you're giving comments, whatever things, right? So once we started from office or reaching here, before that, at least 10 likes or 10 comments you are given to your LinkedIn or Facebook or anything else, right? So the volume of the data is increasing. But for us, that is not a big deal. But when you're looking at the business perspective, the data is very important, right? So all the data, for example, if I'm launching some product, the product going to be in the market, then I'm getting the review, then I'm keep on watching how the product in the market, isn't it? So when I'm looking at that product in the market, what is the review? It's going to be 5-star, okay, fine. If it's going to be 4.5, then it's a bit dull. Oh my God, it's going down. Then I can understand what are the comments are given. Then manually I'm checking that there's a bad, good, or this color is not good. We can have other color, some choices are there. But as a human being, I cannot take all the data and reading that I cannot do any decision. If I have the system to extract the data, and from that I can analyze how many good, how many bad. Probably you might know the sentiment analysis, right? So using the sentiment analysis, what you can do, like we can get back that information, right? As well as sometimes when people upload the pictures as well. I want to analyze that picture as well, what kind of emotion they're given, isn't it, right? Probably they'll put out pictures from movies or some nice pictures from a movie they'll upload it into that. So what will happen, like, so generally we are watching that, but actually everything has a means when I'm into business. You might think actually, for example, if a friend uploading some picture or if you're giving any command on the LinkedIn or Facebook, wherever, what will happen? So then people say like, some people say that congratulations or thumbs up or whatever it is, some people upload some pictures. For us, it doesn't matter. For if I'm doing business for my product, obviously, I need to assess all the information because where my product is going, that's very important. These all are is nothing but the human being generated data. But if it's going to be a machine, what's going to be? It's going to be temperature, pressure, right? Wall condition, motors. For example, I have a bigger plant. I have a this is like a lane. My operation is like 1, 2, 3, 4, 5, 6. Let's say like hundreds are there. Very big manufacturing industry I have. So each way I have a motor, sensors, and pumps and valves, etc., etc., etc. So each one I have a numbers, like because asset management, probably you might have familiar with asset management point of view. They noted the number 101 E or G generated or pump P101, something like that. They have an asset management tool there. It has a management, and then what they will do initially, they will go and monitor each pump and each valve and generator, everything manually. They go and assess. But after this, because in the middle they have a lot of history, I don't want to drag the time, so just moving to the IoT. So IoT will get the data and sense the even the noise, and it transmit to the system. The system will analyze when the motor going to down or what is the problem in it. Because that is very crucial with respect to IoT. If you're going to be in IoT point of view, then what is the purpose means, then and there we can get the data, we can analyze, we can understand, we can assist the platform, which motor or valve or generator or any other things we can replace it as soon as possible. Initially, like 10 years back, when I'm working with influencers like US, Texas, so where we built the tool called the IntelliTrack. The IntelliTrack is like it will go and check that, and open the wall, then we'll check that, like, but what's the condition? If it is yes or no, we have some push item in the mobile-based app, so we'll give the information. That IntelliTrack will give the output such a way the decision. There's a decision-making software by the time. But now, the plant operator no need to go and check what is the problem in it. I just connected with the IoT, and then I'm extracting the data and all the information. Then it will transfer to my analytical team system. That will be analyzed. That will assess the system, and then it will say, hey, another 2 weeks the motor going to down, shut down. You need to replace, or coil to be replaced, or any other things to be replaced. So in the case, what we used to do, like that's going to be order management. We'll be looking for that. Once the person is approved, then it will go to the order management. Then the person will order the new motor or new generator or any of the new other coil. Then they'll bring back to the plant, immediately they could attend. That is the maintenance. So with respect to the human generated data, it's not a big deal, but when it's going to be plant level manufacturing, I cannot shut down even of never my manufacturing industry. That's because it will hit my productivity, my cost, everything, right? Right. So far, nowadays almost all the environment actually it will connected with IoT. It doesn't matter. And we have a cloud data center, everything's going fine. But still, for example, if I'm getting the analysis of analytics inside of the data and let's say less than 2 minutes, for example. But nowadays the stakeholders are really crazy. They're telling me even the 2 minutes is too delayed, too late for me. Actually in India we have even very also we have a Maggi. The Maggi noodles they can prepare the 2 minutes. So the food will be ready by the 2 minutes. Even the 2 minutes is not enough to wait because they're asking we need immediately because my customer is going my competitor is going very fast, but so that I need to be very faster than him. So that's why actually we build. We have the new technology which is called Edge, and even we have a fork here. Probably when permit like in next session I'll bring that as well. So this guy is going to be a edge computing. So here the major things actually local data analysis and decentralized benefits and cost reduction. Because the moving the data into the cloud and doing all this analysis, it takes a time. It's like a huge computational power is required. Probably you might know that if you go with like the operational capacity of the cloud, these components on all, it's a very huge cost. Because if you take the data from the on-premises into the cloud and then doing all the data massages, because actually data engineering we used to do all the stuff. Okay. So you have to understand that how this is like we can expand the possibilities of analyzing the data. But when using this one, so we can take the information instead of I'm passing the box to the N1, then I'm asking to analyze the information. So there, with the help of my friend Satya, I can ask him to do the analysis. So he can do the analysis, he can bring it back to me. But after that, the data will go to the end. Because instant analysis, I want instant analysis. So this I can say another example in manufacturing industry. If I have the a backup operation for my equipments, then if something is down, then I don't need to wait until to recover that. If it is failed, automatically I can pull the another equipment to start operating. Then I can push down the one which is failed. That also actually I couldn't get a chance to bring that video as well. So if you show that, probably you can understand well with respect to edge computing. Okay, and here it's going to be like obviously definitely we need data source and then edge devices and then a cloud services obviously. So it just lets sandwich. And I can see it's like if you go to McDonald's, you'll get or a chicken burger or it's like a hamburger or anything, right? So underneath additionally, if you want to add any layers, you can add it. If you go to that something like in Subway, so generally if you ask like a bread, what bread you want, brown or black or normal bread, whatever it is, then if you started telling them a lot of topping, ultimately it's become the heavier, so that will enough, no need to take any other things for the whole day. So this perspective, actually, the real-time data will be analyzed in this specific layer, so that immediately we can get the data back to the end user, the data that collected, who is waiting for the time, because they don't have a time to wait until it's going back and coming here. So here we have to do all the analysis, and then it will be like passing to the end user, and then it will transfer to that. Then we can do all the normal process what we are doing so far, right? The things are changing very, very fast. Because 2010, I remember the cloud came. By the time Azure cloud, we have just 3 components. One is dev environment, runtime environment, and it's a deploy like a server, production server. Now, when I look at that now, huge components are there, including my edge computing related IoT edge. Okay. Right, and these are the benefits, as I said, like the cloud computing benefits versus this one. I'll have a nice flow chart this one. Probably I'll share the slides if you want, so that you can understand better way. So the edge computing, so the cloud computing is going to be centralized one, and this is going to be distributed, and then it's a process of data centralized server for data source, and this is going to be a like on demand, like immediately it will take the data. If it is going to be like one shift basis or whatever based on your requirement, we can proceed with that. Okay, and it's completely automated, scalability from the zero touch provision, all the things. I don't want to go through each and everything. Okay, everything. So because we're running out of time, right? And obviously the benefits going to be reducing the latency and improve the bandwidth of efficiency, of course, because the time is shorter. Because if you want to go to the restaurant, go and eat the food, instead of that, we ordered. Now we have a Uber and eat everything there. So if you order simple click, the next another 10 minutes, 5 minutes, we'll get the food at home. It's very fast because we are not really patient. We lost our patience, right? Okay, fine. Right, and this could be like a major thing, like a data synchronization channels would be very helpful for when I'm doing like edge computing, because whenever they implement a new technology, they were analyzing like what exactly they need for benefit of the infrastructure point of view and cost reductions. That's very important. Okay. And of course, definitely we need to consider about the security and privacy concern, because we are playing with the data. So even if you're going to implement like the middle layer, like edge computing, that's going to be data protection and security. And however, like you're maintaining in your cloud, the same kind of policies, everything you can set it up. Okay, that's the important thing. So this is a simple structure. We have a huge one, but we have like Azure IoT Edge is a one small component. It's doing all this process. So I don't have enough time to go through that. Like a demonstration, unfortunately. Otherwise, like I will show that. Probably like we will connect later, or you can reach out me, so we can learn a lot more on that. Okay. Right. So here it's going to be Azure IoT Edge. It's a very important component. By using that in on-premises, you have to configure your things by using your VS Code or Python or .NET or Java, whatever the way we need to build, how you are doing all analytics, you can implement in the on-premises itself, and then later point, we can push back. Generally, we used to have like the mobile-based applications, like offline, probably like a mobile-based database, probably you have understood that, right? Mobile-based SQL servers and all, it will sync up with the mobile-enabled data. Then what will happen, like after we connect to the internet, then we will push the data to this actual server and get back, it will sync with the actual server, something like that, and implement. Okay, so of course it's going to be real-time processing and improving the business, no doubt in that, because the shorter time is very well, like the time is shorter and reducing the cost as well. Operational costing, very important. Of course, you can increase the scalability based on the demand, and security features and integration capability is very huge because we can connect a number of things. This is a major thing which is available just with a single component in Azure. I'm not sure about AWS because basically I have worked with Azure like many years, and obviously you know this guy, the IoT hub which is inside the Azure. So from there we can take it forward, we can do all the analysis. Okay, and how to deploy means easy steps. Because of the time consumption, I put the steps like this. Step 1, deploy the Azure IoT Edge for data processing, set up IoT device. It's a very simple click. Okay, and then when you're going for the step 2, configuration Azure Stream Analytics, which is in Azure itself, so that we can do all the configuration. But with respect to the Azure, all the components configuration, 80% are same, 20% will be depends on the performance of the components, so that you easily can crack it out and you can fix that things. Okay, and then I think in simple and short, what exactly the edge means in block diagram for like school kids level, it's going to be 2 blocks. One is going to be on-premises, another going to be a cloud. And here we have a edge computing. The data will be like transmitted from this camera or any other IoT devices which is connected here. We go and we can build all your machine learning models, analytics everything here. And like we have IoT hub, then you can transfer to the cloud and save the data and whatever you can get back the whole things, then you can perform. Okay. So I believe I completed. Yes, one more slide. The features like compute power considerations. Of course, we need a high power, and then data synchronization. Future, it's going to be like integrating with like federated learnings as well. So on top of the machine learning, federated learning also is going to be jumping to the pool. So get ready to grab that opportunities as well. And of course, integration with quantum is computing. So quantum compatibility in the market. So that is going to be a major breakthrough. So that a lot of opportunities, a lot of job opening for all of us. So get ready with that. So with this one, and these are the examples applications straight away. Smart cities integration and public safety enhancement, smart manufacturing system, that's what actually I discussed a lot. And then health monitoring applications, of course, definitely we need that. And intelligence and transport system, because traffic is like a really huge thing, right? With respect to London traffic and all very huge, and that really supporting to like building the super city. So if you have any questions, you can ask me, or else like after the presentation, like the next two guys ready, so that we can discuss it.
I think we have some time for one or two questions, if anyone is burning to ask one. Otherwise, we can take 10 minutes. Okay, well, right.
Sorry for using everyone's time, but just one question. When you mentioned that stakeholders need everything really fast,
Yeah.
and most of the companies have the cloud computing and all the servers and everything on premises, or they have taken from Azure or let's say Microsoft.
Yeah.
If they are planning to change it to edge computing, how it will be affecting cost-wise? Like, is it really costly, or we can add the parts of edge computing which you showed in the inbuilt structure of cloud computing things? Is it cost effective, or we can directly like manipulate the cloud computing? Let's say whatever structure we have, we can add it, like we can put the edge computing things in between and we can use it directly.
Exactly, a good question. See, basically, pushing the customer to move to the cloud, it's a big challenge for us, because we used to even, we said like these are benefits and all, they used to look at like, okay, and still there are a lot of customers there in on-premises. Hope you believe on that, right? So because actually we are insisting that like what is the benefit, why you want to go to the cloud, all this stuff. But when you're going to, if already they're in the cloud and they want to implement edge computing, these use cases we cannot directly go and tell any customers, because certainly we have to be as even a professional, so we have to reach out them on exact use cases. For example, if it's a typical manufacturing specific solutions, we are providing insights on the stuff. So for them, definitely we can tell them the cost effective. And then like, for example, like a machine downtime assessment and all, that's a really classical example with respect to edge computing. So we have to like do some POCs and other stuff. They will tell them like, instead of 2 minutes, I can make it like in 45 seconds, you can get your output during this, when implementing this edge computing, then that will be correct, right? Basically time is very important rather than money. So that you can suggest such a way. And of course it has like own cost as well, but comparing with the computation speed and our reliability and all, so that this specific things will be definitely we can convince the customer and make them utilize this technology. Is it right? Yeah.
Okay, thank you, Shantha. Thank you so much.